Okay. Now let's talk something about water, right? Normally, solid state or liquid state, which one is more dense? Solid state or liquid state? Which state has more density, highest density? Solid state. Right? Normally, solid state has high density, undoubtedly. But sometimes, in some certain compounds, very few, in very few compounds or substances, solid is less denser, solid is lighter. Right? Solid is less denser than liquid. Example. What's the example? Very easy. Water. In case of water, solid state is less denser. Yeah. Normally, ice float or sink in the water, liquid water. Ice normally float. Ice normally floats. That means ice is less denser. Okay? Got it? Very easy. Right? Okay. So ice is less denser than liquid water. Why it is? Right? Why it is? In solid liquid state, okay, see, water molecule. Right? In liquid state, what will happen? Molecules are continuously moving. Right? Molecules, each and every water molecules are continuously moving in liquid state. Right? Why? Because they have a kinetic energy. Right? If you increase the temperature, kinetic energy also will increase. Right? We'll study in unit 4 kinetic energy. Right? When kinetic energy increases, when thermal energy or heat or temperature increases, kinetic energy also increases. Right? That's why if you heat the solid, it will become liquid, and if you heat the liquid, it will become gas. Why? Because if you're heating, temperature increases. With increasing temperature, kinetic energy increases. So solid molecules are, what about the kinetic energy of solid molecules? Also almost zero, like. That's why they are immobile. Solid particles are immobile. But when you increase the temperature, kinetic energy increases. So they starts to flow. That means liquid state. Okay. So remember, temperature and kinetic energy interrelated. Right? Kinetic energy increases with temperature. Right? So if you increase the temperature, kinetic energy increases. Therefore, this attraction will become negligible. Right? Attraction. When just say this is a magnet and this is a needle. Right? What happens if you move this needle? Okay, this is magnet and this is a ion or ionic substance. Ion mean Fe. Right? You are moving this slowly. What will happen? Close to this. Slowly. What will happen? It will get attracted. Right? It will get attracted. But what happens if you move very faster, very much faster, like this? Can you expect an attraction? Why? When the kinetic energy increases, attraction or repulsion becomes negligible. Right? Negligible. Because of this attraction, this will move towards this like this. But if this speed of this direction is very much larger, what will happen? It will be negligible. Right? That's the thing. If the kinetic energy or speed is very much larger, then what will happen? Attractions are negligible. This hydrogen bond, any attractions are negligible. So when you decrease the temperature, what will happen? If you decrease the temperature, kinetic energy becomes lower and this attraction become considerable, appreciable. Attraction become considerable and it will become, so maximum number of hydrogen bond will be formed. A maximum number of hydrogen bonds will be formed when you decrease the temperature. So when you decrease it to 0 degrees C, I'm talking about water, right? So when you decrease about up to 0 degrees C, what will happen? Yeah. And water will, liquid water will become what? Ice, right? Ice. So you can find hydrogen bond like this. Orderly arranged hydrogen bond, that means tetrahedrally shaped. Right? 4 hydrogens are tetrahedrally shaped. Right? Okay. But it okay then you remember then. So how many hydrogen bond oxygen can form? 2 hydrogen bond. Total water molecule can form 4 hydrogen bond, because right, total water molecule can form 4 hydrogen bond. Only lone pairs of the oxygen can form only 2 hydrogen bond. So maximum number of hydrogen bond around water is what? 4. But that number four is possible only in solid state. In liquid state or any other state, what's the number of water molecule? So what's the number of hydrogen bond around water? Less than 4. Right? Less than 4. It will get maximum water molecule, maximum hydrogen bond only in solid state. Right? Okay. Now, what's the next problem? What's the next problem? Why ice is lighter than liquid water? Why? Because of this orderly arranged regular, orderly arranged hydrogen bond, the structure of ice will be like this. CO handout. Right? Like this. Oxygen, hydrogen, hydrogen, and 2 more hydrogens. Right? Right? So this is the pattern. This is the pattern. It will go better. And what's the final? What's the final thing? You would get solid hexagonal structures like this, like you can see in this handout, right? Okay, hexagonal cubic structure like this. Okay, like a beehive. Yeah, then good. Okay, and this structure is called open structure. This open structure is very much roomy, right? This open structure is very much roomy. That means it takes large volume. Right? Large volume. That's why this structure leads to low density in ice. Right? Okay. So you get like this. and this hydrogen connected to another lone pair like this, right? So there are huge gap, right? You can see. Yeah. But in liquid water, there is no such gaps. Why? This bond will become weaker, right? In solid state, this bond, hydrogen bond is very much stronger. In liquid state, this bond becomes weaker. Why? Because of movement. Liquid state because of movement. So, in this place also, you can find a water molecule. That water molecule can break this bond and exist here, right? Because the bond is very much weaker. So another water molecule can exist here. You can find another water molecule here. So number of water molecule in a specific space volume is increases. So density also increases. Okay. That's all. Okay. So you should understand that decrease in temperature leads to an open structure like this. That open structure is very much roomy, right? Right? It is very much roomy. So that's why ice is less dense compared to liquid water. Right? 9% roomy. Right? Compared to water molecule, ice is 9% roomy. 9% space, right? Okay. See your handout. Page number 4. There is no number for page. Right? Here. Somewhere here. Okay. Not last paragraph. This paragraph. And here something. There is a 9, type 9 and about or bracket particle, yeah. It's not bracket, it's percentage, right? 9%. 9%. It's not a bracket. It's not a square bracket. Okay. That's all. And keep in mind these things, right? Naturally, ice is very much lighter than liquid water, but it's very important. It's very important. If it's not possible, what will happen? In winter season, all aquatic organisms will die. Okay, let's say ice forms. Okay, this is the seabed, and okay, these are sea. Okay. This is the sea surface of the ocean. Right? What happen if the atmosphere cooled? If the atmosphere get cooled, what will happen? This surface. In the surface, there forms what? Ice. And if ice is more denser, that ice, what happened to that ice? It will go down and settle here. If it's more denser than liquid water, go down and settle here. Okay, ice. And remaining, it become ice and settle here. So totally, whole ocean will become ice. Okay. So all aquatic organisms definitely will die. Right? All aquatic organisms definitely will die. And now, what's the actual situation? Ice is less denser or lighter. So, when the ice always form on the surface, and that ice will go down? No. It stays where it forms. Right? It stays where it forms. So, what about this temperature? Temperature here.
What is less than
0 degree C. Right? Temperature here is what? 0 degree C. So remaining liquid water will remain as liquid. Right? It remains as liquid. Okay. But if it will go down, then there's a huge problem. Right? Right? Okay. There's a past paper question on ice formation. You can no, you can't do it now. Right? It's not a chemistry question, physics question. In 2002, April 2002 question. You can do it after you have finished heat. I think it's 4th unit or 5th unit in physics. Right? You can do it now. After that, you can do this question. So this abnormal property of water is very much important, right? Okay, it's very much important in life existence, right? Okay, for the lifestyle it completely will be different, right? Not only the ocean, water bodies like even this stream and rivers, lake, all will get ice, completely ice in winter season. So when again summer starts, there will be no organisms, right? No life in summers. Okay, then as I said earlier, hydrogen bond is not only found in between same molecule. It can occur between different molecules. For example, what about this molecule and water? What's this? Hydrogen bond, right? It's a hydrogen bond. Okay. It's a hydrogen bond. You know, between water molecule is the hydrogen bond or not? Yeah, because presence of OH between water molecule. Between, this is called formaldehyde. You studied it in organic chemistry. Between formaldehyde molecule, between pure formaldehyde molecule, what's the bond? What's the attraction? Just dipole attraction. But between these two, what's the attraction? Hydrogen. Right? Hydrogen. It's also hydrogen bond. Okay. Got it. And see another important thing. RCOOH, that means it's called carboxylic acid. The famous carboxylic acid is acetic acid. You know, CH3COOH. Right? There are many more carboxylic acids. The common example is acetic acid. Right? Okay. Okay. In pure carboxylic acid, there's a hydrogen bond between this OH group, hydrogen in this OH group, and oxygen in this group. This group is called carbonyl group. Carbonyl group. C double bond O. This is called carbonyl group. Right? Hydroxyl group. Right? The hydrogen bond is formed usually. Okay. A hydrogen bond is formed. And because of the strong hydrogen, this hydrogen bond is very much stronger. Because of this strong hydrogen bond, this carboxylic acid normally exists as dimers, right? RCOOH twice exist as dimers. You know dimer, monomer, polymer, dimer. Okay. But remember, the formation of this dimer is not due to covalent bond. It is only due to what? Hydrogen bond. But this hydrogen bond is very much stronger. It is comparable with covalent bond, primary attraction. That much of strong. Right? And draw this here, this page, under this page. Right? Only draw this thing, not this. It's given in the handout. Right?